So hello friends, in this video we are going to see the derivatives with trigonometry formulas. So these are the formulas which we are going to use in the problems now. So 1 plus cos 2a equal to 2 cos square a, 1 minus cos 2a equal to 2 sin square a, 1 plus sin 2a equal to cos a plus sin a the whole square, 1 minus sin a sin 2a cos a minus sin a whole square. So these are the angles. Okay, so now we are going to see the half angle. So half angle means 1 plus cos the 2a which is there, the angle will be divided by 2. So then 2 get cancelled and here the angle will be 2. So 1 plus cos a, okay, equal to 2 cos square a by 2. 1 minus cos a equal to 2 sin square a by 2. This is the half angle formula which has been derived from this. Okay, 1 plus sin 2a divided by 2 half angle formula, which is cos a by 2 plus sin a by 2 whole square. 1 minus sin a, 2 gets cancelled, cos a by 2 minus sin a by 2 whole square. Okay, so with the help of this formula we are going to start solving the problems. So let's start. So question number 1, y equal to root of 1 plus sin x upon 1 minus sin x. So here as you can see 1 plus sin x, you can see it here, 1 plus sin x equal to cos a by 2 plus sin a by 2 whole square. So I can put this here. So y equal to, put this square root as it is, 1 plus sin x, 1 plus sin a is this formula. So put this cos a by 2, here a is x, so x by 2 plus, so plus sin a by 2 x by 2 the whole square divided by 1 minus sin x. So 1 minus sin x is this formula. So cos x by 2 minus sin x by 2 whole square dividing by cos x by 2. So now we are going to simplify it by dividing cos x by 2 both numerator and denominator. So y equal to cos x by 2 divided by cos x by 2 plus this bracket remains same, sin x by 2 divided by cos x by 2 square upon, in the denominator also we are doing the same, cos x by 2 divided by cos x by 2 minus sin x by 2 divided by cos x by 2 bracket whole square. So now cos cancel, cos cancel. Okay, so sin upon cos is tan. So in the next step y equal to, this all remains the same, root cos 1. Okay, this cancel out, sin upon cos is tan x by 2 whole square divided by 1 minus sin upon cos, again same, tan x by 2 whole square. So now the next step y equal to root this square and this root gets cancelled in the numerator. As you can see, I can write the root as half, so half into 2, the 2 cancels, and in the denominator also same, square and root gets cancelled, so we are left with y equal to 1 plus tan x by 2 divided by 1 minus tan x by 2. So tan a plus b, which is tan a plus tan b upon 1 minus tan a into tan b. So now we are going to apply this formula here, as we have y equal to 1 plus tan x by 2 upon 1 minus tan x by 2. So now we have the 1 here also into 1. So 1 is tan 45 pi by 4. So here all angles are in radian, so pi equal to tan pi by 4 plus tan x by 2 upon 1 minus tan pi by 4, which is 45 x by 2. So tan 45 is 1. Okay, so tan a plus b, which is pi by 4 plus x by 2. This is the standard formula we have used now. So we have simplified it till here. As you can see, in Calci also it shows radian r. You can change it, press shift and then mode. Here it shows, if you press 4 it turns to radian, 3 is degree, so I am pressing 3, now it is showing D, which means degree. Again shift mode, press 4, it is showing R, radian. So tan, in the numerator I am putting this pi, so for pi shift and this pi symbol comes, and then in the denominator I am putting 4, so bracket close and then equal to, so it's giving this symbol that tan pi by 4 radian is equal to 1. We got the answer. In the modes you can switch the modes accordingly as per your requirement. So turn it off, shift AC off. So now we can do the differentiating y with respect to x on both sides. So d by dx of y equal to d by dx of tan pi by 4 plus x by 2. So now this whole term I am considering as x, as we have the formula of derivative of tan x is sec square x. So x I have considered pi by 4 plus x by 2, okay, into derivative of which I have considered as x, that is pi by 4 plus x by 2. So in the next step you have to write this sec square pi by 4 plus x by 2 as it is into derivative. So this derivative goes to both, derivative of pi by 4 plus derivative of x by 2. Okay, so in the next step, this as it is sec square pi by 4 plus x by 2 into derivative of this. Here the x function is not there, so it is just constant pi by 4 into derivative of constant is 0, so it's 0 plus derivative of this half comes out, so derivative of x, which is 1, so 1 into half is half, it is 0 here. So again this whole terms goes to both sec square pi by 4 plus x by 2 into 0 plus into half. So the answer remains half answer remains half sec square pi by 4 plus x by 2. So this is the answer. D by dx of y, you have to put it everywhere. Okay, so next question number 2, y equal to log of root 1 minus cos 3x upon 2 upon 1 plus cos 3x upon 2. So this is also similar question. We are going to apply the formula from here. 1 minus cos 2a, the formula which I will be using now here. So 1 plus cos 2a is 2 cos square a, 1 minus cos 2a, 2 sin square a. Okay, so I have to adjust this angle to get 2a. So I have to put there 2 in the numerator. I need the 2 in the numerator. Okay, so I am multiplying and dividing by 2 in the numerator and denominator. So I will be getting y equal to log 1 minus cos 2a. A is 3x upon 4. 2 into 2, 4. Okay, 1 plus cos, same in the denominator also, 2a, 3x upon 4. So I got it, multiply, divide by 2. Okay, so I got this. So now I am going to apply the same formula, log of root. So I can put this 1 minus cos 2a, 2 sin square a, 2 sin square a, which is 3x by 4. So 3x upon 4 upon 2, 1 plus cos 2a, 2 cos square a. So a is 3x upon 4. Okay, so now here I can cancel out this 2 and again the root goes to the numerator also and also for the denominator, and then same, the half and 2 gets cancelled out, square and root. Then we have left with sin upon cos. So this gets cancelled out. The log and y remains the same, y equal to log of, so this cancel out. So sin upon cos is tan. So tan 3x upon 4. Okay, so I got this till here. So from now here I have to start differentiating y with respect to x. I have simplified it till here. Try to simplify as much as possible and then you can apply the differentiation. So derivative of d by dx of y equal to d by dx of log bracket tan 3x upon 4. Put the brackets to avoid the confusions. So d by dx of y equal to derivative of log x. I have standard, it is 1 by x. I am considering this tan 3x upon 4 as x. Consider x. So 1 by x into derivative of which I have considered as x, tan 3x upon 4. Okay, so 1 upon tan I can write it as cot. Again we are using the trigonometric basics. Into derivative of tan x, I have the formula which is sec square x. So sec square x is 3x upon 4 into derivative of which I have considered as x now, 3x upon 4. So in the next step I have to derive that. So rest all as it is, cot 3x upon 4 into sec square 3x upon 4 into derivative of this. So 3 upon 4 gets out and derivative of x is 1. So our answer finally equal to 3 upon 4 into cot 3x upon 4 into sec square 3x upon 4. So I have taken that 3 by 4 in the front. So here d by dx of y equal to final answer. Okay, So put this everywhere. So next question 3, y equal to e raised to power 2x minus e raised to minus 2x upon e raised to 2x plus e raised to minus 2x. So this is the question now. How we are going to simplify it now? You can see the power e raised to 2x minus e raised to minus 2x. So minus 2x I can write this like this. I can write it like this, 1 upon e raised to 2x. So same I am going to do this in the denominator also. This minus sign I am writing it 1 upon, so that I can get it in the plus. So here I am going to do the cross multiplications. Okay, that is plus e raised to 2x into e raised to 2x, cross multiply, minus 1 into 1 1, okay, upon e raised to power 2x, and divide by this into this e raised to power 2x plus, okay, into e raised to power 2x plus 1 into 1 is 1 upon e raised to power 2x. So this cancel out, so we have left with this. So base, if base is the same, then you are just going to add the base same, add the power. So e raised to power 2x plus 2x is 4x minus 1, e raised to power same 2x 4x plus 1, y equal to this. So I have simplified it till here. So now here we are going to differentiate it by u by v rule. So we are going to apply the formula of u by v, which is v derivative of u dx minus u derivative of v dx into divided by v square. So we are going to apply this formula here. So differentiating y with respect to x on both sides, so d by dx of y equal to d by dx of this whole, which is e raised to power 4x minus 1 upon e raised to power 4x plus 1. Okay, so apply u by v. So v is denominator, e raised to power 4x plus 1 bracket into derivative of u is the numerator, e raised to power 4x minus 1 minus e raised to power 4x minus 1 into derivative of e raised to power 4x plus 1 upon denominator e raised to power 4x plus 1 whole square. Okay, so now here write it as it is, e raised to power 4x plus 1 into, now derivative goes to both. Okay, so here the derivative of constant is 0, and e raised to power 4x, e raised to power x, we have the formula of derivative, e raised to power of x is e raised to x. So e raised to power x, which is 4x, into derivative of which I will consider as x is 4x. Okay, then derivative of constant is 0, then go to this minus e raised to power 4x minus 1 as it is, derivative goes to again same both, derivative of e raised to x is e raised to x into derivative of which we have considered x is 4x. Okay, derivative of constant is 0, this remains as it is, e raised to power 4x plus 1 whole square, this as it is, e raised to power 4x plus 1 into e raised to power 4x into derivative of this, 4 comes out constant and derivative of x is 1, so 4 minus this also same 4, as the derivative of x is 1, so I am writing it here 4 e raised to power 4x into e raised to power 4x minus 1 divided by e raised to power 4x minus 1 So here I have made the mistake. As you can see, the V is plus and here I have written minus. So before, check it in every line, this comes as it is. Okay, so please do it carefully. As I have done this mistake, try to avoid mistakes. Okay, so it will be plus. So that's all. Thank you.